Good morning, students. In this lecture 21st of mechanics, we will start our unit 2, that is chapter 3rd, which is inverse square law force. You have already studied these forces in nature in your 10+2. Out of these 4 forces, you might have studied 3 forces. Actually, there are 4 types of forces operational in nature. First one is gravitational force, second electromagnetic force, third one is weak force, which you might not have studied, and fourth one is strong force. First we will discuss gravitational force. As we all know that if we have 2 bodies having masses, then there will be gravitational interaction between the 2 bodies because of their masses. So therefore, this gravitational force, it arises because of the masses of the interacting particles. And because this gravitational force, it is always attractive in nature. There will always be gravitational force of attraction, and it can never be gravitational force of repulsion between the 2 bodies. So that's why, what is its nature? It is attractive in nature. Then, the law which we use to explain this gravitational force, that is Newton's law of gravitation. All you have studied in your senior secondary level. So this gravitational force, it can be explained by Newton's law of gravitation. And according to the Newton's law of gravitation, first of all, consider the coordinate frame in which there are 2 bodies. One body is placed at origin O of the coordinate system and another body that lies at point P. The mass of the body which lies at point P, that is small m, and the mass of the body which lies at point O is capital M. So both the bodies, they will exert gravitational force on each other, but because the mass of this body, it is larger, so what will happen? This body, it will attract this body towards itself. So the direction of gravitational force will be inward towards in the direction of PO. And what is the position vector? R vector is the position vector, that is, it is the distance between the 2 bodies. Suppose r cap is the unit vector. So in this way you can see that this gravitational force, it is in the opposite direction to that of r cap. And according to Newton's law of gravitation, the magnitude of this gravitational force, it is directly proportional to the product of 2 masses and inversely proportional to the square of the distance between the 2 masses. And this G, it is the constant of proportionality, and this is known as universal constant of gravitation, and it is equal to this. Now this is the magnitude form. What will be the value of this force in vector form? Means along with its direction. So we know that, what is the definition of a vector? A magnitude multiplied by its unit vector. A magnitude of vector multiplied by its unit vector, it will give us magnitude, it will give us direction. So both will give us complete vector. And what is the direction of this F vector? It is in the direction of PO. So it will be PO unit vector. And what is this PO unit vector? It is in the opposite direction to r cap. So its direction is minus r cap. Therefore, this negative sign indicates that the force is inward in nature. It is acting along the line joining the 2 particles and inward. So it means this negative sign, it indicates that the force is attractive in nature. And you can clearly see from this Newton's law of gravitation that this force, it is inversely proportional to r square, which is known as inverse square law. So this gravitational force, it obeys inverse square law because force is inversely proportional to r square. And then here you can see that at any value of r, this f, it will be non-zero, except when this r, it approaches to infinity. When this r, it approaches to infinity means when the two bodies or the two masses, they are at infinite distance from each other, only then this gravitational force will be zero. Otherwise, when this distance is finite, and then this force, it can be small, but it will be non-zero. So it defines that this gravitational force, it is a long range force. Why? Because it is zero only when r approaches to infinity. When the distance between the two bodies approaches to infinity, only then it is zero. So it is a long range force. And any interaction, it is because of the exchange of the particles. So what is the particle which will be exchanged between the two bodies in case of gravitational interaction? That is graviton. Graviton is the field particle, exchange particle, which is exchanged between the two bodies and which results in the gravitational interaction between the two bodies having masses. Then second one is our electromagnetic force. It arises because of the charge on the particles. The two particles which are interacting with each other, if they have charge, then they will have electromagnetic force between them. And this electromagnetic force, as the name indicates, electro means electric and magnetic means magnetic. So it has two parts. But the magnitude of electric part, it is larger than magnetic part. That's why we always take into account the electric field vector instead of magnetic field vector in case of electromagnetic forces. You will study in your waves and vibration in next semester that this electric field part, the ratio of electric field part to magnetic field part, it is approximately 377. So means this electric field part, it is greater in magnitude than this magnetic field part. It is stronger. Electric field part is stronger than magnetic field part. So this electric field part, it is described by Coulomb's law of electrostatic interaction. And we know that if the two charges which are interacting, if they are like charges, means same charges, positive positive or negative negative, then the electromagnetic force between them will be repulsive. And if the two charges which are interacting, they are unlike charges, means positive negative or negative positive, then the electrostatic force between them will be attractive in nature. So what is our Coulomb's law of electrostatic interaction? First of all, consider the coordinate system in which we have two particles having charges on them. Charge on the particle which lie at point O is capital Q, and here which lie at this point P is small q. And the distance between the two particles is r. And as the two charges, they are like charges, plus q and minus q, plus q and plus q. So the force between them will be repulsive in nature. Repulsive in nature means the force will be pointed in the direction of OP vector, means in the direction of r cap. So this Coulomb's force, it is directly proportional to the product of the magnitude of two charges and inversely proportional to the square of the distance between them. And this 1 by 4 pi epsilon naught is the constant of proportionality. And this is the magnitude form. In vector form, any vector, it is given by its magnitude into its direction, which is given by the unit vector. And its unit vector is OP cap, and this OP cap, it is in the direction of r cap. That's why replace this OP cap by r cap. So again, here what you can see is this, that this f will approach to 0 only when this r approaches to infinity. So again, this electromagnetic force is also a long range force because this f approaches to 0 only when the two charges, they are at infinite distance apart. And one another thing, that is, as this F is inversely proportional to 1 by r square, it means it is also a inverse square force. It obeys inverse square law. And the field particle, the particle because of the exchange of which this electromagnetic interaction takes place, it is the photon. Photon is the field particle in this case. So next force is weak force. You will study about this weak force and the strong force in your nuclear and particle physics in 6th semester. So here we are just studying these forces briefly. So weak force, what is weak force? It is the interaction between leptons with other leptons. It also arises because of the interaction between leptons and mesons, or leptons and baryons. Now what are leptons? All the electrons, positrons and their neutrinos. They come under the category leptons. And what are baryons? Baryons are actually nucleons like neutron, proton, hyperons. All these are baryons. So these interactions, they are known as weak forces. And these weak forces, their range is very small. That is, if the two bodies, they are not at these particles, leptons and baryons, they are not at infinite distance apart, but the distance between them is large, then there will be no weak force. It means the range of this weak force, it is very small, that is only 10 raised to power minus 16 meters. So it is a very short range force. And the field particle, because of the interaction of which this weak force arises, it is neutrino. Next comes strong force. Strong force is the nuclear force. So it is the force, as strong force is the nuclear force, means it is the force which will exist inside the nucleus. So if it is inside the nucleus, it means it will be the interaction between protons and neutrons, and these protons and neutrons collectively, they are known as nucleons, and these nucleons, they come under the category of baryons, which you will study in 6th semester of nuclear and particle physics. So it is basically the interaction between mesons, baryons and mesons. Means it is the interaction between mesons and baryons and mesons. And baryons and baryons. Then what will be the field particle in this case? The pi mesons, there are 3 types of pi mesons: pi plus, pi 0, pi minus. This plus, 0, minus, these are the charges on these pi mesons. These are the field particles. So why there are 3 field particles? Because this nuclear force, it can be the interaction between proton and proton. It can be in between proton and neutron. It can be the interaction between neutron and neutron. So in all the 3 cases, the force is between the 2 charged particles, one charged particle, another neutral particle, then again between two neutral particles. So according to the situation, any of the field particle will participate. Then, as these nuclear forces, they exist only inside the nucleus, and the size of the nucleus is about 10 raised to power minus 15 meter. It means these nuclear forces or the strong forces, they are also the short range forces. So this is all about these 4 kinds of forces. So what are their relative strengths or relative magnitudes? The nuclear force is the strongest one. So that's why we have taken 1 here. And this electromagnetic force, it is 1 by 100 times of this nuclear force. Then comes weak force. It is 1 by 10 raised to power 13 times the nuclear force, weaker than nuclear force. And this gravitational force is the weakest force. It is 1 upon 10 raised to power 45 times smaller than this nuclear force. So this is all about forces.